registration. Now I'm recording. Registration is underway for summer semester. 2452 will be available online, and I'll be the one teaching it. There'll just be one section of that out there. So there'll be a number of people that are taking 2451 that will not take 2452. And that's not because I got a problem with 2451, but because in computer support, they only need one networking class. So they only need to take 2451, but they don't have to take any further beyond that. And in networking, if you're doing the Microsoft approach, that's the only one of the Cisco's you have to take also. So there'll be a number that do not go on to the next course. So the two sections have combined to be into one section, and there'll be a lot less students in it next semester. But that's just the way we got it built. That's not anything against the instructors or anything else on it. So that happens, because I have students sometimes go, why is the number so low on 2452? And I'm going, okay, it's this. Now for the 2453, usually just about everybody goes through 52, goes through 53. Summer is, for the CIST classes, we do it in 8 weeks instead of 16 weeks. The classes that do the full summer semester run 10 weeks. I personally prefer the 8 weeks for a couple of reasons. One of them, I guess you could sort of say both of them are selfish, but not really. For one reason, that on trying to convert these classes to being summer versus the other semesters, an 8-week session is a whole lot easier, because 8 weeks versus 16 weeks. So basically we'll do in each week in the summer what we did 2 weeks this semester. So that makes an easy conversion for me on any classes that I have to convert that are out there in Blackboard already set up on 16 weeks. It's real easy for me to set them up on 8 weeks. And so in the 10-week, the second thing is using the 8-week instead of 10-week. That gives an extra 2 weeks at the end of the semester, at the end of the summer semester, for a break there for both the students and me, that it's time I can then take off, although I don't always take all of it or how much ever of it off. But it gives some more possibility to take a longer something to do between on it, because theoretically we're not supposed to take leave during the semester, the instructors. And if y'all have looked at the calendars, between other times, like coming up in May, it'll be only like a week or so between the two, after you build in required instructor days at the end of the semester that we have to stay around for several more days. So there's not much time there. And in December, there's really not a lot there. We do have several week or two there, but it's a holiday for 1 week, and then like another week. And so it's not much time to take annual leave on it then. And with the rate I earn annual leave at, which I've been with the state for more than 15 years, I'm at the maximum amount. So I get somewhere close to, supposed to get 4 weeks annual leave a year. It's not really possible if I do on that, if I could take off at those times, but I'm needing to work on things a lot of times, so I can't take that much.
So with the classes, it's crammed, right? So if we have six chapters in 1 week, or 3 chapters in 1 week, and then the next week we do 3, instead of doing that, you've got 6 chapters in 1 week, right?
You only got 14 chapters to do for the whole semester, somewhere 14, 16, just like we do right now, chapters. So you're basically,
so I'll do 2 chapters of.
So where we've been doing basically 1 chapter a week, you'll be 2 chapters a week.
Okay. Is there a way that you can get the syllabus so that I can start reading ahead? you know, and go out, because I buy the book. So I'm
We'll
wondering if
go
I
through
can.
the whole book.
Okay.
So we'll be going through the whole thing, exactly how I'll lay it out, because this course has 17 chapters. That one's got 14 or 15 chapters. Aren't consistent on how many chapters I got in each of the courses. I
Mhm.
wish they were. I wish they'd set them all at 15 or 16, and then it'd be a lot easier to set up. But
Right.
they've got somewhere around 16 in each of the three classes, but it varies. So when I lay the syllabus out, I'll pick the order on it. But basically, we'll be doing um, 2
2 a week.
chapters a week. Okay.
Okay. That'll work.
Um, the other part is for that course, most students consider it easier than this course, and I would also. Although of the three Cisco courses, I'd put these two as the hardest two and the third one as the easiest on it. But you got to know the stuff from the first two to get to the third one. And when we used to have four, that the third and fourth one were easy ones, everybody was concerned. Didn't take a whole lot of time on the student's part, didn't take as much time on my part. When I took them, we actually only, where we were taking class all day long for a week for each of these courses. For those two courses, the third and fourth one, and they don't have a fourth one anymore, they combined all the stuff that was in 4 into 3 and added some stuff. Um, and, but still made the end lighter. That we actually had the afternoon off every day. That we'd get through in the morning and be through with the class every day on it just about that week. And some of us would work a little bit in the afternoon, but we'd have covered the chapters each, that we'd covered what we were supposed to do for each day in about half a day or just over that. And that went with all of the instructor trainings. The ones that did it in Florida, I had to do it in West Virginia. They actually, one day that they changed, they were doing it in Jacksonville. One day they changed it this when they were going to do it, and instead of meeting in the morning, met in the afternoon, because they were launching a satellite that morning, and so the instructor said, "Y'all can all go to the beach and watch this satellite go up for that morning." So it's been that way. We've complained for years that it's not balanced out well, but every time they revise it, they'll say, "We got it better," and we'll go teach classes and go, "No, you didn't. You just put more stuff in the first two courses."
Mhm.
So I think y'all can, those that do it will do well in it. The other part is it is a hands-on course. So there's not as much theory to learn. You're going to be things that you learn in it, you're going to be actually doing. So they're going to teach you how to use the protocols, and you're going to use the protocol. So it's not like we're doing in this class, and like this chapter right here is a really good example. There's not a heavy theory that you're having to remember on. You're doing the stuff, which makes it easier also for almost every student on that. Now there's the occasional student that is the bookish one, that it's a little more frustrating to them because they'd rather be reading and learning it. But for most people, it's easier. So that's what we'll be doing. Basically for summer, just think that you're also on time planning for your classes. Realize you're studying. You're going to need to study twice as much each week as you're doing right now. Which the theory is always in colleges is that how many hours a week your class is supposed to meet. This one's supposed to be 6 hours a week. That you should be studying separate, besides going to class 6 hours a week. You should be studying 6 hours a week outside of class to make a C in the class.
Mhm.
In the case of y'all doing it online, that means y'all should be studying for this class probably somewhere about 14, 15 hours a week. That includes taking the tests and doing the labs. That's all part of studying, okay? So that right now you should be spending about that amount of time, which is why 3 to 4 classes is full time. Because if you are spending the time on them that everybody says students should be spending on it, And some students do, some students spend more, some students spend less, but that's on average. If you think about that, that's 40 hours a week, real quickly right there. And so it is a full-time job then, which is why those that are working full-time, I know like Todd and some others, I'm not sure who else in here right off, that I don't recommend normally y'all take a full-time load at the college. Okay, is that you don't have time to, besides they've all got other stuff out there in the world to do too.
Well, in addition to this, I'm studying Active Directory, and I'm studying GPOs, and I'm studying Python, and learning Linux. And it's just part of what I have to do for work.
So that's the parts that I would say on it for y'all. But for registration this week, as I sent out in the announcement email, so I think I sent it by email also that we were doing it. I am available to advise this week, and I can also register you, or you can register yourself. The other part is, and I registered a number of people yesterday. Todd's registered.
Thank you.
He said he was registered. Yes, he is. You can register yourself, or I can go on and register you. If I register you, I'll need your PIN number to get you registered. But either way, last week in the meeting, the school said to have students do their registering, and several of us had a big dispute with that right off the bat, that we're going, we have no problem with students registering, but we're going, there's not every student can register themselves, even having been advised that they get, it's not the easiest process on it, and that it's a whole lot better for us to do it in a lot of cases and saves some on it. So either way it'll work. The other one is for those of you that are in the degree or diploma program, you can also, besides asking me which courses, and this is where I'm going to get the information from, is the pathways out there in course documents show you our projected path for you going through as a full-time or part-time student entering spring or fall of what courses you should take each semester. And we actually set our schedule up using that pathways document, that every course we've got listed for summer on there is available in summer. Now, it may get canceled before summer gets here if nobody registers for it, okay? Or there's hardly anybody in it, and we'll have to figure out some way around on it. But generally, that we are going to initially at least schedule every class that we have listed somewhere on those pathways for summer is on the schedule at this point. The other part is that shows you exactly, if you do those courses in that order, that they're going to be there, and that you've got a path to go on which courses take each semester. Now, you go through the part-time one, depending on how many classes you take each semester, that may change on that one. We projected it on you going time because we had to come up with something. So it's, but that's there. Now, those do need updating. 1401 is still listed on them. Which we don't teach anymore, which is the other introduction to networking class we had. It was a little bit more Windows oriented, and it was a little bit lower than this one. And we said, everybody really needs the level this class does, and let's just teach one intro networking class, which made scheduling easier too. And then there's something else. Oh, it's still got 2454 listed on it for Cisco. And instead of that, the students, whenever they're supposed to take that, they need to take some other networking class, be it the Linux Unix class or one of the Windows classes. So, and that's the way we changed the thing when it changed. All right, so if you need advising, let me know, and I'll be glad to suggest to you classes to take for summer. If you're not going to be full-time, if you'll tell me you're only going to take one class for summer, so like Todd told me he only wanted one class for summer, that was easy. If you, that I can tell you, all right, here's, if you only want two classes, I may tell you, here's three classes I'd suggest to you to choose two of the three from. Because I also try to give a little bit of leeway to y'all. Electives, we've got them actually chosen in pathways, but that doesn't mean you have to do those, unless if you are a cybersecurity student, if you will take exactly the courses we have listed in pathways, Then when you graduate, you will get 2 degrees or diplomas because you will have met the requirements for networking also. Because we realized if you took the correct electives in cyber, you actually met of what we could choose in cyber, that you could actually meet the requirements for the networking degree, and without taking any additional courses, which has really been nice on that one. And those 2 are directly related, so that made sense. All right, any questions for me on registration advisement? So it started this week. It doesn't close at the end of this week, although the schedule shows registration, returning student registration, it just shows it as this week. It really doesn't end this week. However, also, if you're going to take certain gen ed classes like music appreciation, those you need to register for yesterday or today. They fill up quickly. Now, others like English 1101 or Math 1111, you can register for those much later. But the other part is, if you wait very long, in a few weeks after we start doing new student registration and get them being registered, we will be looking at the schedules out there. And if we've got sections with no enrollment or very, very low enrollment in them, we're liable to cancel them. And it may have been a section you intended to take, and it may have been that we would have kept the section going if we'd had one other student in it. And we also tend to know who's in them, because we look at who's in them and go, is that a class, that student, that if there's a few students in it and we go, wait a minute, there's a student in there that has to have that class, and we happen to know on them because they had been advised by us, that's the only time they could take it, then yeah, we play that into consideration too, and they fold something else to merge into it from another direction. So we try to also keep the student interest in it as we work on that. But we will be canceling classes when it gets to later into April, when we get into April at some point, later April, probably mid-April, that we'll start canceling some classes because of no enrollment, because we got to get ourselves around, and we got to have enough numbers in our classes for our job also. So there's that play too, because we get considered on how many classes we teach and also how many students we got in classes. Needless to say, I got plenty of students in classes this time, and that's where all we're supposed to have. You may have thought somebody else was going to be in this class with you this semester, and then it turned out they're not. They split it on the last minute just before the semester started, because I had too many, and split the class in 2 and gave half of it to another instructor. The only other one really can teach it. So they chose to do that. So that, but 2452, if you register for that one, you've got me for it, because I have to be the one to teach it, because the other one that would have also can teach it is got more limited load than me, and her load's already full. She can't add a class for summer. So I'll have to teach it no matter how big it gets. And so that's that. All right. Any other questions for me on anything generic right now? Because here's the other part. We've only got 35 minutes left till 12 o'clock. And I've got 2 hours worth of information to give to y'all today. So we're going to have a problem on that one. So I'm going to get through right now quickly the first half of the chapter. And then how many of you could attend this tomorrow at the same time?
Let's go.
Or how many of you can't attend tomorrow at the same time? And I'll give you credit for having attended to not do the discussion just for attending today, or if somebody else joins in tomorrow, they'll get credit for this week also. So don't worry about that part. Because I'm thinking to do this at the same time tomorrow morning and then do the last half, which actually is the harder part of the whole thing. I've also got a recording out there that I've pointed y'all to, or should be pointing to out there, that I did last fall, and actually I'm doing Thursday afternoon that I did for CompTIA last fall, and then I'm going to be doing one for North Carolina Computer Instructors Association on Thursday afternoon. So the subnetting I'm not going to do today. Okay, there's no way. I did this lecture yesterday in the in-person class. Remember, that's a high school class, so y'all, none of y'all can take it. That it's just for the Catoosa high schools. And that's how far I got in an hour and a half. And so we'll roll at this point on this, because this is IP version 4 in the chapter. This one actually used to be 2 chapters in the book. Now they've moved it to 1 chapter. And to me, in a way, this chapter has, and I've actually got videos out there already that I recorded a number of years ago in your class also, should be sitting there available to you, that you can watch also, where I've lectured on it in the past. And all of this material in this chapter has not changed since I would say 2000. Okay. The actual material to it hasn't changed, but we actually started using from the late 1990s, got more into doing the subnetting stuff, where before that you really didn't have to worry about it much. Because I will tell you this much too, as far as the subnetting, I got MCSE, which is was Microsoft's highest networking certification. They don't even have something to replace it currently. They're working on some different things. I got it without knowing the stuff really in the last half of the chapter. When I went to take the Cisco, I learned this last half of the chapter, went, ooh, now I know stuff better, and they hadn't taught it in any of their materials that I had studied. But they had a few questions on the test, but I didn't, they were going, what in the world are y'all talking about? Because you never told me anything about it. So it is important. So in IP version 4, and we're looking at 4 in this chapter. Next chapter, we'll look at version 6. So we're not worried about that one right now. So with IP version 4, your addresses, as we've already seen, are 4 bytes long, normally expressed in decimal. They're actually stored in binary in there, and it's in 4 parts. There's a number, a number, a number, and a number separated by periods. That's how it's normally expressed. They range from 0 to 255, each of those 4 numbers. Now that's because it is each of them 1 byte long. And if you remember when we did number conversions back a few chapters ago, that in 1 byte, the biggest binary number converted to decimal that you can store in each one is 255, because that would be 8 ones. And if you added up those 8 columns, you get 255. So the numbers each range from 0 to 255. So in that was the approach they used. Now, beyond that, they've split it. And this is going from original, it was a class-based system, which I'm going to really teach you on in this part. The second part of the chapter in the subnetting is when we get out of the class base and look at things not doing it on classes. Technically today, no, we're not doing it exactly on classes anymore, but we still refer to everything in terms of the class and work with it in terms of that. Although technically we're not doing by classes, we'll see how they were originally done on that. So you do still need to know all these classes, but you're not going to get given a class A, B, or C address, as you'll see in a little bit. So what they did was they said, okay, we're going to split it when it was classes purely on those octets. And each of those 4 numbers is considered an octet, O-C-T-E-T, because it really fit back towards octal, so they called them octets. But remember octets, because they are octets. That's something you could get asked. Okay? So the whole address is 32 bits long, or 4 bytes. And then they split it. The first part of the address is what network is it on, and the last part of the address, which I'm probably backwards from y'all on it, the first part of the address is network, the last part of the address is host. Okay, so the rightmost portion of that address is the host, the leftmost portion of it is the network that it's on, and so the address is going to tell us that. Now, to go with that, they came up with subnet mask. What the subnet mask does is that it tells us which portion of that address is the network portion and which portion is the host portion. It's also expressed in binary and is 4 bytes long also. However, the portion that is the network portion will have binary ones in it. The portion that is the host portion will have binary zeros in it in the subnet mask. So it always starts with ones and it always ends with zeros, and there's no mixture of ones and zeros in the subnet mask. And all the subnet mask there is for is to distinguish which part of the address is the network portion and which part is the host portion. Now, at this point, what we're doing today, it breaks on each of the octets. Tomorrow, we'll see how you get to split it within, that we'll be able to borrow bits that belong to the host portion and put them on the network portion. And that makes the subnet mask more complicated. But for right now, your subnet mask are going to be expressed in terms of 255s and zeros. If it's a network portion, it'll be 255, all binary ones. If it's the host portion, it'll be a zero. Now, once we get a little further, when we get into tomorrow, we're going to see that the host portion, that the first host byte can be split up and be made part host, part network, and that will change that specific one to not being just 0 or 255, but can be a set of numbers in between. But otherwise, the rest of them, the other 3, or like today, all 4 of them, would be zeros or 255 in decimal. Does everybody see the idea of what subnet mask does? So all it's there for is to look at an address, and it tells us this part is the network, this part is the host. And that's an important part of that. Initially, that when it was purely class system and there was nothing else to it, that was exactly where they came from. Then as we had to start changing, as y'all see in a minute, that there's a problem with it, that changed. So it will be expressed in that way. That's long form. The other way the subnet mask will be expressed is a slash and a number that tells you how many bits of that address is the network portion put after the IP address. And actually, when we get an IP version 6, it does the same thing. So if it was 255.0.0.0, which actually is a class A address, then that's long form. Short form would be /8, because the first 8 bits of that address tells us what network it's on. The remaining 24 bits that we don't tell it there because we know there's 32 bits long, so you subtract it from 32, is the host portion. But that's all the subnet mask does. So they go through and show you the different ones on that, and they actually show you it expressed in the 255, show you in bit there in the book, the long out there of all 32 bits, and then they show you in what they're calling the prefix length, or that's the short length, okay? And that you'll see it. For instance, when y'all are doing it on the Cisco routers and switches, they quite often will give you the address and subnet mask using the short form with the slash whatever. But when you put it into the Cisco router and switch, the Cisco router and switch, when you do the INT command to give it the address on the interface, requires you use the long form. So you got to be able to switch from short form to long form. Okay. They mention here in the book about logical ANDing. Here's what I will tell you on that one. You really don't need to know that. Okay. That's the way a lot of times a lot of people tell you about how you have to do to look at an address and convert it to which part's the host and which part's the network. So I'm going to go to the whiteboard right here real quick and just draw one real quick for you, an example, and show you why I skipped this whole logical and ANDing. But if logical and ANDing makes sense to you and you go, I like doing that, that's perfectly fine. It's just, to me, it's extra work to me. So if we've got an address, wait a minute, I think I can do this. All right, so if I've got an address, wasn't what I meant to type, but it'll work. So if we've got that address, and then we've got a subnet mask, and subnet mask happens to be 255.255.0.0. Okay? This one up here, what they're telling you is you can convert it all out to binary ones, which y'all can all do. I'm not going to do because that would take too much time, draw too much out. Because you really can do straight off right here. And you convert this to all binary also, and then you look at it, and with the logical ANDing, they're saying if they're both 1, you'd put a 1 down here. If one of them has a 0 in it, you'd put the 0 down here and put on a cross. And when you'd finish up, you would end up with an address, in this case, with 129.28.0.0 when you converted it back to decimal. Okay? And not even going to the binary, you can look here. Now, when we get into the ones in the last half of the thing, and I put an extra period here, and I'll never be able to get rid of it. So ignore that second period there between the 255 and the 0. It's not there. So my suggestion to you, when they're purely class ones like this, just look at it. All right, if there's a 0 and a 0, we're not going to use those parts. If there's a 255 there, we're using those. So our answer on this, there's 255 under the first one, so we keep 129. There's a 255 under the 28, so we keep the 28. We got a 0 under the 36, ignoring the extra period. So there's a 0 there in the subnet mask, so we don't keep anything. And there's a 0 under the 17, so we don't keep anything. And there's our network address. It's supposed to be sharing out there to y'all because it says it's sharing.
I see the IP. I see the IP address. I see the subnet mask, but I don't see what you're doing with it.
Oh, okay.
You know what I'm saying? In real time, I don't see it. Okay, now I see it.
So it doesn't show when I'm typing on it. Okay.
Yeah. No.
Well, I was hoping using text boxes would work better because when I use the pen, you're depending on my drawing ability. Although what we did yesterday, we ordered a part to help on that we've actually got a pen thing to draw with on the little drawing pads we ordered. But I don't have
tablet. Very cool.
So that will improve things. But I was hoping that would work nicely. But now y'all see what I got right there. That I brought the 129 down because it was 255. I brought the 28 down because it was 255. The 36 I did not bring down because there was a 0 there. I'll put 0. And 17 I did not bring down because there was a 0 there, so that's 0. So that is the network address right there is 129.28. And then we got zeros in the host. Now, that's another little piece I will tell you right now too. Host addresses always end in 0. And then there's going to be another address we're going to see, which if they're full ones, it's 255, or that's all binary ones. So I'm going to put all B1. Will actually be a broadcast address, which I'm going to talk about in just a second. The rest of the addresses between there, and we'll see that better tomorrow when we go through the subnetting as I demonstrate through that. But that is going to be another. So that's just, to me, instead of doing all this logical ANDing and ORing, and particularly when you're on class boundaries, don't worry about that. You really don't need to do it. And even on a test certification exam, they may say in terms of it, do it, but all they're looking for is the answer, and they don't care how you get the answer. Okay? Just as long as Todd doesn't look at my paper while I'm taking the certification test also. Otherwise, they don't care how Todd gets his answer. So the next thing they talk about is network host and broadcast addresses, which is what I just started talking to you about. So I actually jumped ahead, didn't realize that was the next page in the book. The network address is just the network portion and zeros in the host portion. The binary zeros technically, right now on class addresses, it's actually a 0 in each octet. Okay, so your network, and so that's not, and you would never give a device that address of 129.28.0.0. That address is not usable. It tells us the network. Okay, everybody follow that part? The host address, let's skip. The broadcast address is the other one I mentioned right there. And that is where, when you use that address, that says whatever this is, packet this is sitting in, and remember we are on that layer, that it's got this destination address. If it's got 255 in it, or all binary ones, then that says that goes to every machine on that network. That is used quite commonly. You as a user aren't going to use it very often, although I did when I was managing a Unix system years ago. Did use it occasionally because I wanted to send a message to everybody, but not very often. More often what that's used by is that's machine-to-machine communications. For instance, we've mentioned DHCP already. And that the first thing it does is that the machine coming on makes a broadcast asking for an address because it doesn't have an address yet. So, and it doesn't know the address of anything on the network because it just got turned on and had nothing in it. So it has to do a broadcast that sends it to everybody. Everybody looks at it, and only the DHCP server says, oh, I can answer this. The rest of them look at it and go, I don't know anything about this, and just ignores it. The DHCP server broadcasts back a message of here's an address you can use. Has to broadcast it back because that machine that it's going to give the address to has no address yet, so it can't send it to the specific machine. So y'all see where there's broadcast. That's just one example of broadcast. They also are broadcasting out, looking to see who all's out there on there all the time and other stuff. So there's a lot of messaging going on, machine to machine, not humans involved in it. And so there's a lot of broadcasts that do occur. You actually do want to keep them down to a degree. So there's certain protocols we don't use nowadays because they went way overboard. And then the third one is your host addresses, which is everything in between those two numbers. And that is a 5, believe it or not. Okay. So 1 through 254 in this example, which is most of the time, are going to be your host addresses. Okay. And that's what you're going to actually assign to each machine is one of those addresses. But the bottommost one, it's network. You're not going to use it. The topmost one, it's the broadcast address. That doesn't get assigned to a specific machine either. Y'all follow on that? And in actuality, we're looking at binary ones on these addresses, being in binary and looking at all binary ones here, and then here you'd be looking at the range in terms of that it's a binary ones and zeros on this one. Any questions on that?
From yesterday, because the 254 reminded me of it. In Cisco's training, they would never switch it up and change a default gateway where they had a .1. They would never change it over to a .254, would they? Because I know I've watched a lot of training videos, and some people use 254 as the default gateway, and most of the people use a .1. I guess some people want to be different, but for the most part, with Cisco, do they just stick with .1 as the default gateway throughout our training?
Usually,
one of the questions
I
wrong.
see with Cisco usually reserves out the first 5 addresses for default gateways and also machines that for servers that they usually use the first 5 addresses to use for that
Static, right.
default gateways, and that they'll say don't use the first 5. However, from a Unix world, and that's where I came from first on networking. Generally, and what I did back when I was doing that, because that was what everything was saying about the way to do on it, and before I even knew this stuff very well, didn't hardly, that we actually use 254 usually as the default gateway, that we use the highest address we would assign to the default gateway on it. So,
But in the test, they wouldn't change it up in the test since we just learned that, right?
on the test, they're going to tell you in terms of what they're looking at as the default gateway, but they wouldn't be. But so you could have something on there. Like on Microsoft, I know in the book we're using right now, Teaching Server 2016, it uses 250 as the default gateway. Okay.
Okay.
And again, that's going actually along the same line of what I just told you. Usually Cisco's doing, except they're using the other end of it. They're holding the top 5 highest values for things that are going to be not changing on it, that have going to be fixed addresses, and that Cisco seems to usually like to do the bottom 5. Okay. Although you could have more or less in a place. And so
there was a test on a question last night on the test, and I was just, it kind of threw me because I didn't see a .1, but I did see a .254. So I selected 254. I don't know if I got that right or wrong. I totally forgot.
So
I'm just curious.
So on that, you've just got to, and technically, which is not recommended at all by people, is that you can pick any number in that whole range of 1 to 254 as your default gateway. But the normal root recommendation is that you use either the highest number or the lowest number as the default gateway.
Okay, thank you.
Okay.
Yes, sir.
So that will vary on that one. So host addresses is everything in between the network and the broadcast. Now, next thing they come in, they mention about unicast, broadcast, and multicast, which I think I've already mentioned in this class to y'all before, but I'm going to mention real quick again. Unicast is when you're sending the message to one machine. Okay, so the destination address goes to a single machine. Multicast is when you're sending it to a group of machines. And what that means is, instead of having to send out a number of whatever the message is, and where this really comes into play nowadays is streaming. Instead of it streaming that information across in a whole bunch of different feeds to all of the people that are listening to it, it sends one across addressed to the group of them using a multicast address. Okay, so it's going to more than one machine. But you're only having to send the message across the network once, so you don't clog the network up. Does everybody follow that idea? Now, IP version 4 poorly did a job on addressing for it. IP version 6 does a lot better. And then the third one is broadcast, which I've already discussed. That's when you want to send a message to every machine on your network. Okay? And there's where you use the 255. So what you're going to mostly ever be involved with using is unicast and broadcast. That's what you're going to normally ever see. Just be aware, multicast says we're sending it to multiple designated machines. Okay, but you really don't usually have to worry any further about multicast than that. And if you look in the book, you'll notice it's got the least amount of information spent on it. It's got a half of a page, and the others spend about a page and a half on each of them. So that tells you importance. All right, next one is when they created this whole system, and that with this, and we'll talk about numbers in just 1 second, but they had created public addresses and private addresses. Exactly why they did that back in 1980 or right about there where they did IP version 4, I don't know, because there was really no reason to, although it turned out great in the late 90s that it was there. It was where people thought people would do something, but they really didn't have to do it. Public addresses are addresses that appear on the internet. So if your device is connected to the internet, it used to have a public address. Now this changed after the late 90s, but let's stay right now with it has to have a public address because technically it still does, but we're going to tell you a way around something that happened. Private addresses were addresses that you would use on your network for devices, for a network that was not connected to the internet. So they weren't used outside of your network. Those devices didn't connect any further. If you think back to 1980, there were tons of networks. And as you go through the 80s and into the
Yeah, I'll get it. I'm in class, but I'll get it.
There was, most networks were not connected to the internet. So they said, use these private addresses for those networks because they weren't connected out there, and so they didn't. So these were addresses the internet does not recognize. We still use those. What happened in the late 90s, we ran out of IP version 4 addresses. IP version 6 started appearing then, but we found a solution and we actually used this. The private addresses, what we realized was we can use NAT and proxy servers to convert a private address inside a network to a single public address outside, and we didn't have to give every device a public address. Prior to that, when I set up Swainsboro Tech onto the internet in the 90s, in early 90s, every device in there had a public address and could see everything that traveled across the internet. We got given, and that's where class A, B, and C came into. But with private addresses, everything that starts with 10 is a private address. That's a class A address. Class B private addresses start with 172.16 through 172.31. That's the hard one to remember. Big thing is remember the 172. If you remember that, you're usually okay, but you don't have to remember the 16 and the 31 on it. The third one is class C is 192.168 it starts with, and that's a class C private address. Now think about all the examples I have given y'all except for the one on the screen right here, and I actually intended to do that when I started typing it. I told you I made a typo, and I typed 129. I meant to type 192, and then I was going to make it 68. Think about all the addresses you ever see out there in the book and different things you read out there that when they're teaching you about it, what do they use? One of those private addresses, because it's not a real address. Any of you that know a little on the telephone system realize that when you see telephone numbers on movies or in songs, except for one song in the 60s, that it's never, they come up with always the same exchange, no matter where this phone supposedly located that they're giving out a phone number for. What's it start with always?
5.
What do they start with when they
555?
555, because the telephone companies have reserved out that as 555 exchange does not exist and is never used. So use those in all of those places, and if somebody says, ooh, now I know what the White House phone number is because they were watching a movie about the White House and it said 555-342. They call it, it doesn't do anything. It's a non-existent. There was a song in the 60s that they actually put a real regular phone number on, and every time somebody gets that number assigned to them, after a month, they call a phone company and say, you got to change my number, because they get all these people, they'll hear the song playing, and then they'll try calling that number. So this is the same type thing, the private addresses here. They're not recognized. If you try to send something to that address out on the internet, it goes nowhere because the internet says, I don't know what it is. Okay. Default gateway sort of gets mentioned right here. But what happens is now what they realized is we could use one public address for GNTC, not thousands in here with all of the machines we got scattered between the campuses, but just one public address, put private addresses all in here, put a NAT server or proxy server sitting out there, right there, interfacing the internet. And it takes the private address inside, converts it to that public address, and that NAT server remembers what it did. Okay? That NAT proxy server remembers what it did, and when the message comes back, it goes, okay, I remember on that of what I had sent out, and converts it back to the correct private address, sends it to the correct machine. We saved tons of public addresses that way when we had run out of public addresses. So yes, public addresses, private, are used, and that you'll see them. Okay. Loop back address. This is a big inefficiency of IP version 4. I forgot. I was going to mention that to the students yesterday, and I skipped over that piece. I just realized loop back. Instead of just saving one address out there for a loop back address, and you only need one, they took an entire segment of them. Everything that starts with 127 is a loopback address. No, you don't need that ton of loopback addresses. So that was an inefficiency of the system. Okay. Now, the next one is they tell you about the classes, Class A, Class B, Class C. And if I can get through this, we'll be in good shape right here. Class A was for the largest group. And those, and with my luck, this was printed on backside pages. What they did was Class A addresses all start with a binary 1 in the first octet and then have a 0. And then the address head uses the rest of that octet. Okay? No, I told you wrong. Starts with a 0 in the first position, and then the other 7 positions are used. So it always starts with a 0. So any Class A address has a binary 0 as the first position in the first octet. What that tells you is that those addresses all start between 0 and 127, or you'll see it as going up to 126. Okay? And the reason for that, where I just told you, it could be 127 or 126. The book says 127. You get other books, sometimes they'll say 126. Because of that loopback address uses 127. So some people say that loopback address is a Class A address. Some people say, no, it's not a Class address. So you'll see that. But I've never seen on any test of any type, certification or test, that I've taken that be any problem, that you had choice of one or the other. So it could appear as 127, it could appear as 126 as the high number on it. What that tells you is you've either got 128 networks available on Class A or 127. Technically 127 because loopback's not a network. They assigned out Class A addresses to the largest organizations, and the numbers are actually following in the book. It's on the next page. On the online, obviously, it's where I'm coming on down. So remember that 128 of the number of them, that they range from 0 to 127 or 126. And there are on each network 16 million, some odd number, of hosts available on each network. Now, how many networks do you know of that have got 16 million hosts on it? That was the problem. They gave these out to the largest companies back there in the early 80s. AT&T got one. IBM got one, and a few others, and I don't know who all. AT&T actually still has one because instead of leasing them out, they gave them out. And AT&T sued there in the late 90s when they tried to take it away from them and said, you gave it to me, you didn't lease it to me. And they won in court. So I think they still got their little old number one on. Everybody else gave theirs back to keep the whole internet working. Okay. B, and so remember on that one, the 128, and remember 16 million. You don't have to remember 16,777,214. I can't remember that last part of it. Okay. If you remember 16 million, you're close enough. You'll get questions correct. The choices you'll be given, you'll know which one it is with Class A, that there's only one choice that would be 16 million. Actually, there other choices usually are your B and C and something random picked out of there. Class B, those start with 10 in the binary. And so they range from 128 to 191 is their range of numbers. Okay. I'm telling you the binary because when I learned it, I didn't know the binary, and I was going, where did they come up with these numbers from? Why did they go from 0 to 127, 128 to 191? And then when I got told how binary works, I went, oh, they did have a system to it. And on those, there are 16,384 networks that they can issue out. Well, remember the 16,000. And then on each network, there's 65,534. Remember, 65,000 is the number of hosts per network. If you had 65,535 hosts on your network, you had to get a Class A. And look at how many addresses were being wasted. You'll see where we wasted tons of. Class C was designed for small businesses. They had no idea we'd have networks in our homes at that point. That was science fiction somewhere way in the future, not 13 years down the road in 1993-95, starting to appear when the World Wide Web appeared. And those range from 192.0.0.0 through 223. Okay, so 192 to 223, so that's really a 110. Okay, that's the start in binary. That one, to me, is the easiest one to remember in terms of the number of hosts per network. 254 goes back to what I've got sitting here on the screen because it uses the last octet for in terms of it. Okay, and so it's 254. So I can always remember that one. And then there's 2,097,152. Remember 2 million possible networks. Well, if you think about those numbers don't work today. So that was where we went to, where we ran out addresses. There is Class D and Class E also. Class D was multicast, and we didn't use many of those. Back to the loop back one, I'll throw you this one real quick, which comes out of the next chapter, but just for your information. IP version 6, the loop back address that's reserved out there for it is 31 zeros and a 1, so it's 1. And that's the only one they put in, IP version 6. That's also the only IP version 6 number I can tell you off the top of my head. Class E is experimental, you'll often see. A lot of books won't even mention it. As Todd has studied through all these different books, he may have seen some books said about A, B, C, and D, and some said there's an A, B, C, D, and E, like this book says. E is experimental or something like that. The government saved it for itself, the U.S. government. Remember, the internet is a U.S. government invention. The military uses it. I understand the intelligence agencies use those addresses, and that I've never seen one of those addresses in use. Or if I've seen one of those in use, I couldn't tell you about it because if I did, I'd have to kill you. So I may or may not have seen a Class E address ever in use. I can't tell you. But that's what those are used for today, and for when they're doing experimental stuff, developing the internet further, they'll use those addresses to be playing with. They're not used for other type things. Does everybody follow on those out there? The last thing I'll mention, and we're stopping right here, is there are agencies all through the world, organizations that assign out these IP addresses. ARIN is the one that does it in North America, ARIN. And remember the ARIN, you'll see that occasionally. The other ones you don't really need to worry about, but they administer issuing, if you want a network address, that's who you apply to, and they give you one. Now here's the part on IP version 4. At this point in time, for the last 2 years, essentially most of the time they can't give you one unless somebody just gave up one. And they're not going to give you a Class A address, and they're not going to actually give you a Class B or C. They're just going to give you a part of one. Because they have run out of addresses about 2 years ago, I think it was. It was a year or 2 years ago, and I think it's 2 years now, which is also what we had occur back in the late 90s. And then when they went to using NAT and figured out they could actually not give organizations a whole public IP address, just give them 1, 2, 3, or 4. And GNTC probably actually has about 4, uses 1 for their website, probably 1 for communications out of the college. 1 maybe actually comes into a certain server. or whatever, but just a couple of them is used where most of the machines are through that other one that is shared among everybody. Now, did that make sense what I just told y'all all on? I just gave y'all the Reader's Digest version of the Reader's Digest version of Basic IP version 4 addressing. And my voice says, you just ran nonstop. Thank you, Todd, for stopping me a time or two to catch my breath.
Yeah, sure.
Okay. As you can see, there's a lot of stuff in here. So tomorrow we'll go on through and do the rest of the chapter. And we'll mention a little bit on the broadcast domains, which the broadcast domain says it's everything within that subnet or network that's got the total network portion of the address. Broadcast only go to there. They don't jump across routers when you do a broadcast. Broadcast stays purely on that one side of the router. So it does not go out the default gateway back to the default gateway we were mentioning earlier. So that's what the broadcast domains are.
So this is how I learned it. This is how I learned it. Collision domains, there's many. Broadcast
Collision domain includes everything physically connected on your network.
Yep. So
the broadcast domain stops at the router.
Yep.
Okay. And then we'll get into the subnetting, which in the physical book, those of you that have it, starts on page 364, and I'm going to go through drawing all over the place on the whiteboard tomorrow on this. If you can't attend it, I will record it. The other one is, whether you attend it or not, you may want to watch where I've pointed y'all to the recording I've got out there that I did for CIN, CompTIA Instructor Network, that I did last fall for them. And actually on them, when I did that one, that I went through and did everything in that presentation. I actually pre-typed it all in there and didn't use the whiteboard. When I taught the number stuff on there, I used the whiteboard, and then some people commented they had a problem seeing stuff very well drawn on the whiteboard. So then when I did the one on subnetting the next week, I actually had it all typed into PowerPoint slides. So that one might be useful to y'all to also watch. And remember, you can just register out there at CIN to see it, where I give y'all the link to. I think you have to do register, and just tell them you're a computer instructor, because probably all of you are teaching somebody else, at some time about how to use something on the computer. So you are teaching, and there's no membership fee or anything else, and they don't send you anything or anything except for when they have a new seminar coming up. So it's not anything that is a problem. Okay. So I'm going to stop at this point. We've gone 10 minutes over. So I literally did run 1 hour on today, and ran about 45 minutes on a lecture that should have taken a little longer, but that's the way it goes. All right, so tomorrow at 11, I will see y'all again, and we'll go through as good as we can on subnetting. But I will tell you also on subnetting and the VLSM, that to me is probably out of the whole book the very hardest thing you will learn in this whole course. Mm-hmm. I know for me, it was the very hardest thing I learned. Okay. But if you don't get it, it's just one thing in the class, and it won't make a difference on you passing or failing the class. Yeah, it might cost you a letter grade, but I really doubt that. It's just a little bit of the whole thing. But if you can catch that, it makes other things fall in place for you too. So it's important to know, but it's not a do or die thing. Okay. But I'll try to explain it as best I can, and I'm going to be drawing on the screen right and left on that one. In the classroom, there was one school I taught at that they had marker boards all the way down the long side of the room, and when I gave this lecture, I filled up those boards all the way down the side of the room. And classroom at Catoosa, when I go to teach this tomorrow over there, and I will record that one too, and I will put it in y'all's class for you also, my lecture on it, my video of it. I've only got one small board, and you're going to see me erase it a number of times. I will wear the eraser out because there's that much to write on the board for this. Okay, so y'all have a good day, and take care. Don't drown out there in all the flooding, because we've got plenty of water sitting out there. There's a lake in front of the school that only appears there when we get a bunch of inches of rain. The baseball field is underwater, so, and it's supposed to keep on raining all week. So if you see an old man that resembles me with a longer beard come by that also has a big boat with him and asks you if you want to catch a ride with him, his name is probably Noah, and you may well want to take advantage of it. Okay?
Yes, sir.
Because it looks like we're in for lots of water again. Talk to y'all later.
All right, thank you.
Stop the recording. And if y'all got any more questions, I'll be glad to talk a little longer with y'all.